Welcome to the course module of Communication Engineering, and in this video we are going to apply the concept of envelope detector that we have already discussed in my lecture classes. So let's try to solve this gate problem which was asked in gate 2011. So let's first read out this statement given in the problem. Okay. So here a message signal MT equals to cos 2000 pi t plus 4 cos 4000 pi t modulates the carrier CT equals to cos 2 pi FCT, where FC equals to 1 megahertz to produce an amplitude modulated signal. For demodulating the generated AM signal using envelope detector, the time constant RC of the circuit should satisfy. So here we have to find out the time constant RC of the envelope detector circuit. And here are the given options. So let's try to solve this problem. Okay. So here we can see this is the envelope detector circuit. So here we have to apply the amplitude modulated signal, and here we have this envelope detector circuit, right? So output will be taken from this terminal, right? And here we have to find out what will be the discharging time constant of this envelope detector R into C. So here we have already discussed in my lecture class that to ensure the envelope detection of the AM modulated signal, this circuit should satisfy certain condition regarding the discharging time constant. So normally the charging time constant of the circuit should be ideally 0, but the discharging time constant should satisfy this particular condition. So here is the condition. This RC time constant should be much larger than 1 upon FC, and it should be less than 1 upon FM. So this is the condition for to ensure the envelope detection using this envelope detector circuit, right? So here you have to just make this comparison based on the given data. So here we can understand that this message signal MT is a multi-tone signal, right? Here we have the two different frequency component, and the carrier frequency FC is given as equals to 1 megahertz. So we can find out these two limits. Okay, we can find out these two limits. So if you calculate this lower limit, okay, then here we can calculate this lower limit after substituting the carrier frequency equals to 10 to the power 6 hertz. So if we calculate this value RC should be much greater than 1 microsecond. So this is one of the condition that we have to satisfy, okay, while designing this envelope detector. So now we have to calculate what should be its upper limit, right? So we have to choose this particular message frequency FM. So here, because it is a multi-tone signal, if we choose this two different frequency component, right, then we can get these two different conditions. So here we can see if we choose M1 equals to 1 kilohertz, corresponding to this RC time constant that we are going to get is 1 millisecond. Okay, it should be less than 1 millisecond. If we choose this FM2 equals to 2 kilohertz, then this value will obviously it will be less than 0.5 millisecond. So normally you might think which value we should take to ensure the envelope detection, right? So here you can see if we choose this first condition RC less than 1 millisecond, and let us suppose if we are designing the envelope detector for which this RC value is somewhere around 0.6, in that cases this condition will not be satisfied. The meaning is that we have to take that particular condition that will satisfy both these cases, right? So here if we choose this RC less than 0.5 milliseconds, in that case, it is satisfying this condition as well as this condition also. So let us suppose if we choose any RC value somewhere around 0.1 millisecond, okay? So in that case, this 0.1 millisecond will be less than 0.5 millisecond as well as 1 millisecond, and therefore this condition will be more appropriate choice, right? We have to choose this RC less than 0.5 milliseconds. I have already explained in my lecture classes that if we choose the RC time constant too large, in that cases there will be a diagonal clipping of the envelope part is going to occur. and that time the message will not be demodulated properly. So here you can see this condition. We are having RC should be much greater than 1 microsecond, and this RC should be less than 0.5 millisecond. So here you can see the proper option. So I think this option belongs to option B. Okay, so I think this will be the right answer, 1 microsecond. This RC should be much greater than 1 microsecond, and it should be less than 0.5 millisecond. So I hope this discussion must be clear. If you have any doubt, you please first go through the lecture, okay, video lecture that I have described about the envelope detector, and then you go through this particular video to get this solution easily. Okay. So thank you for watching this video. If you having any doubt regarding this problem, you can drop me your message in the comment box. So thank you for watching this video.